Hello guys, this is Expert Wanda and today we are going to see the Leetcode question that we have. Today is 129 and this question is 129 sum root to leaf nodes and leaf numbers. So you are given a root of binary tree and that containing digits from 0 to 9 only. Okay, we have digits and that is from 0 to 9. Each root to leaf path in the, you can say, tree represents a number. Okay, so each root to leaf path in the tree represents a number. Okay, next, for example, the root to leaf is 1 2 3. So 1 is root and 2 3 is leaf. 3 is leaf, you can say, and represents the number 1 2 3. Return the total sum of all the root to leaf numbers, and test cases are generated so that the answer will be fit into 32-bit integers, and leaf node is a node with no children. Okay, so in this sense it is saying that we have this root, this is our root node, and this is our leaf node 1, and this is our leaf node 2. Okay, sorry, leaf node 0 and leaf node 2. Okay, so these are leaf node. So you can see that, and how we will represent this, that we will talk about later. So it is saying that we have to represent this into the number, right? And then we have to do what? These numbers should be fit into 32-bit number. Okay, so we'll come to here again and we'll try to implement this one. So first of all, let's suppose if someone is given like this, low 1 we have given 2, we have given 3, and one is this is our root node and this is our leaf node, right? So first of all, from 1 to 2, there is one path is 1 to 2. Okay, this is root node and this is our child node from 1 to 2. So if you re-represent this one into a number, so it will become what? 1 2. Similarly, if we go from 1 to 3, it will become what? 1 3, right? And if you do the sum of these two, so it will become 25, correct? And this would be your answer, correct? As you can see. Now we will talk about another example that we have here is 4 we have, and similarly we have 9 we have, 10 we have, right? Sorry, 0 we have, and this is 5 we have, and 1 we have. Okay, so if we'll go from here to here to here, right? So it will become what? 4 9 5. Okay, we are going actually from here to here first time. So 495 we have. Next time we will go with what? 4 9 and 1, because this is our leaf children. Okay, so we'll means we are going to from here to here to here. Okay, so it will become what? 4 9 1. Next time what we have? We will have only one path. This path is left, right? So we'll go with 1 0. So it will become what? 4 0. If you do the sum, it will become 6 9 9 18 18 and 2 20 and 2 22 22 2, right? And 4 4, and there is what? 2, right? So become 10. So this will become 1026, right? Answer. Now if we'll talk about constant, right? So the nodes of the in the tree is what? Range into 1 to 1000, and value will be 0 to 9 of the node value. Okay, this is we have given. So this question is very important because this question has been asked in the Facebook multiple times, and similarly Google and Apple, Amazon, Microsoft, all the other companies also asking these questions. So you can say this question is very important for the interview purpose, right? So topic is touching the you can say topics, that is tree, DFS, binary search you can use, right? So similar question you can see on the Leetcode, that is path sum, binary tree, maximum path sum, and smallest string starting from the leaf. If you're not able to find this question, please bring in the comment box. I'll help you there. Okay, let's go to the solution. Okay, and then we'll try to implement this one. Okay, so solution, if we'll talk about the solution overview, right? So there are you can say 3 DFS ways to traverse the tree, right? And we know that DFS already, right? If you're not aware with, you can do some hands-on using the DFS algorithm. Okay, so there are 3 ways of we can say DFS to traverse to the tree. That is, we have what pre-order, post-order, and pre-order, right? If you know about DFS, it is what the first way is to implement what pre-order, right? Pre-order, and then another is you can say post-order, and third one is what in order, correct? Okay, pre-order, post-order, and in order. And if we'll talk about the pre-order, right, we know that first we have to go with left, then we have to go to right, and then we have to go to this one, right? Similarly for the post order is there, in order is there, right? So we will see, you can see that letter, okay, pre-order, post order, and this one. So actually DFS we can implement using the three ways, that is pre-order, post order, and in order. So in this way we will see pre-order, right, and you can see post order, in order. We can implement this one also, okay. So the you can say why we use, right, what optimal strategy we will have to solve this problem, right? So for the optimal strategy to solve this problem, right, we'll go to the root to left, right? First let's suppose if this is root, right, so we'll go to the left side, right, and then root to left will go, so it is called pre-order, right? First we'll go root, then we'll go to upper left, and then if we'll talk about our another things, right, like right and those things, so this approach will call pre-order, right? And if we'll go to the post order, first we'll go to left, right, and then we'll go to this root, right? Similarly, if we'll go to the in order, first we'll go to the left, then right, and then root, and then right, like this. So if we are going with what root and then left, right, from root to left, then it is what it is called DFS, pre-order traversal. And to implement it, one has to follow the straightforward strategy, that is you can say root, then we can say left, and then we can say right. Okay, this is the strategy you have to follow, correct? And so that since one has to visit all the nodes, right, and the best possible time complexity here is linear search, right? So hence if you say all the interest here is to improve the space complexity, right? So there are three ways to implement pre-order, that is iterative, recursive, and Morris, right? So if we'll talk about this pre-order traversal, right, so there is three way, so in which in the iterative way you will get the best time complexity. If you the Morris, right, approach, then you will get the constant space, correct? And if you use the recursive approach, this is the simplest one to write the, okay. So if you are in the interview, I will suggest you use the simplest one because it is easy to write, okay. But you have to see what do you need: the time complexity you need, best time complexity you need, constant space need, and best way to write the problem you need, right? So we'll see the iterative approach, right, first, because this is the best time to complete, right, and we'll try to implement this one. So if we'll talk about the iterative pre-order traversal, right, so here we can say we'll how we'll do the implementation, right, of the pre-order traversal, you can say, okay, with the stack. First of all, we'll push root onto the stack. Let's suppose if this is a stack, right, this is open, so we'll first of all we'll push root here, okay. Then what will happen, while the stack is not empty, we'll check the stack is not empty, we'll pop out a node from the stack, we'll remove get it pop out from here, and we'll check and update the current number, right? If there is a node in the leaf, right, means there is a left or right, so we'll update the root to leaf, and we'll do the sum, right, and we'll push right and left children put into the stack. So only one here what we have to do, if node is leaf, right, if we will push another thing and we'll check if the node is leaf node, then what we will do, we'll update root to leaf sum, okay. So we'll update there, And similarly, if we will push right and leave left children into the stack, and we will return the root to left sum, we will have to do the sum, and then each time we will update it. Okay, so what we have to do, first of all, we have to push onto the we have to push root into the stack, and while stack is not empty, we'll pop out the node from the stack and update the current number. Okay, and if the number is if the node is leaf, then what we will do, we will update the root to leaf sum, and if it is right, we'll push right and left children onto the stack, and we'll update the same thing again and again. Okay, so if we'll talk about what I'm trying to say, let's understand this. So we'll take a root to left leaf node, right, and we'll take one current number. Okay, so I'll take one int, there is a, we can say, root to leaf. Okay, sorry, leaf. Okay, root to leaf will take, and do that, we'll say root to leaf also. Okay, so we have root to leaf, and this is nothing but our what, 0. And if we'll talk about another one, is current number, right? So we'll take int current number like this, and this is what we have, 0, and we will update each time current number, right? So to do that, what we will do, we'll take a pair of tree node and its integer, right? So, and we have to take in the queue, right? So if we'll talk about array q, array dq, we'll take array dq, and it is what we have. Let's suppose we'll take in the pair, right? So I'll take like this only. So it should have a pair, it should have into a pair, and that is known onto the stack. We'll add onto the stack, and this pair will take what, pair of tree node and its number, right? So let's, what I'm trying to say, we have pair class, and in pair class will take what, tree node, and another will take what, integer, and this pair will go to where, onto dq, right? So we'll take dq, and we'll add onto here, right? So dq will take what, dq will take this pair of tree node and integer, and that is called our stack. I think we are good. Now what we should do, we'll add root onto the stack. So to do that, we'll take stack dot will to push, right, and then we will add what, new pair we should add, and this pair is nothing what, that we are doing, right? Root will add, and another will add what, 0. Initially that we have seen, right? Root was 4, and then its value is 0, right? Number is 0. So we have initialized this one. Now what we will do, we'll do the traversing, right? How we will do that? We'll check while, and we'll check not null, not empty, we can say. There is a method is empty, is empty method, and we'll check if the stack is not empty, then we will go with what, and we'll take a pair, and that pair will nothing but what, stack dot will do pop, and we'll get this pair, and this pair is nothing but our what, this pair we are getting from what, this pair will get from here, right? And we'll say like this. Okay, now if we'll talk about once we will get the pair, right, what we will do, we'll say root and p dot get value. You will get your root value, right? You have got your root value, p dot get, and then we will get the, from the pair we will get the value, from pair value, you can say. Okay, next time what we will do, we should check if the root is not null, right? If root is not null, means we have some value, Then what we should do, we have our current number, right? On the current number, what we'll do, current will apply this formula current into, first of all we'll multiply with 10, and then we'll do root dot value, so that we'll update our current number each time, correct? So if it's a leaf number, we will update our root to leaf sum, right? So what we'll do, we should check if root dot its left kid have some value, right? Or it's a not null. If it's a leaf, so we have to do is null, right? If it is null, and similarly we should check with root dot right one, and if it is equal to null, means both are leaf node, right? If both are leaf node, then what we will do, root to leaf we have, right? And this root to leaf will do plus what, our current number will add on to the current number will add, correct? Now what we will do, if these are root lift current and this one, okay, left and right, so we will update our root to leaf. If this is not, then we should add onto the stack, right? If this is the leaf node, then we will find our we will get the root number, current number, and we will add onto the root leaf, right? And if this is not you can say leaf node, then we will not update root to leaf, but we'll update onto the stack. I think you got. So let's add onto the stack. What we will do, we'll say new pair, and then we'll add this one like this. But here what will come, pair is what? Pair will come from what? Root dot left, correct? And onto the integer, this one, it will become what? It will come, you can say current number, right? Current number. Why it is giving the error? Because we are taking this one, but we will take this one, because we are taking construct of this one, okay? Now this will work, okay? Similarly, we'll take this one and we'll add here, okay? Here we'll take right, okay? So if left and right is not leaf, right? So here if left, if leaf node found, if leaf node not found, okay, then we will do these things, okay? I think understood. Once these are done, so we'll complete our else, then we'll come to our you can say while loop, and then we'll come to our this one, you can say method on, right here. So before that, what we will do, we will return here, let me return what, root to leaf. So let me summarize this one. So what I have taken first of all, I have taken a method name, and that is sum, and it is taking root. We'll take we have taken root leaf, then current number. We have taken a stack. A stack will be the pair of tree node and integer. So we have added a stack root onto the stack. Sorry, root on the stack. Then we have what we have did. We have did root we pass and then 0. Similarly we'll get our root, and after doing the pop, and we'll check onto the if it is not null, we'll find our current, we'll update our current number. If this is root leaf, or if this is the leaf nodes, we will find our root to leaf, and similarly we'll find our stack value. Stack.push will do if it is not leaf nodes, and finally we'll get our root to leaf. Okay, so I'm getting what p is root value, right? No, sorry, this would be key. Okay, this would be key value because PWR function contains value as a key and value. Okay, so I'm getting error. I'm getting out 145, 25 should be the answer. Okay, so let's understand why we are getting here error. First of all, what we have did, let's start from here. First we have taken this you can say this one, right? Then we have taken what, these variables. Then we have taken while condition. In this while condition we have taken these conditions. Then we have what, if this is root null, will not completed here but will come to here. Okay, this is the thing. If this is not null, correct, and then we will do these things. Okay, let me do 25. Okay, so if this is null, right? If root is not null, then we will do this one. And if this is leaf nodes, right, so we'll do this one. If this is not the leaf node, then we'll do root dot right and current number, root dot left and right. Okay, so actually here we should do first, we'll go to the right. First we should go to the right, I think. Yeah, and then we'll go to the left. 135 is coming. What I'm doing mistake. Okay, I got it. We got our root, right? We got our root, but we have not updated our current. We have to get our current also, right? Current is will take from p dot get key, get value. How can I do this mistake? Yeah, let's submit. Yeah, see you tomorrow. So why we're getting the mistake? What we have updated our root, right? But we have not updated our current number. So if you'll do this update, so it will work. Okay, so first we have taken the root leaf, and we'll return this loop root leaf later. So after that, what we will do, we have taken the stack, and this stack will take a pair of root node and integer. We'll push the root first, and then we'll get the root, we'll do the pop, and we'll check onto the, we find our root and current number. We'll check if the root is not null, then we'll find our current number using this formula into 10, and then plus root value. Then we'll check if this is leaf nodes, then we'll update our root to leaf, and if not, then we'll update our stacks, right, like this. So that's all for today. So if we talk about the time complexity, right, if there is total number of node is n, right, so it will become if you write here, so time complexity become what, O of n, right, if n is the number of nodes, right. So because we have to visit each node, right, and if we'll talk about the space complexity, right, so it will become what, if the till the height, right, So height of, if h is the height, right, so we'll say O of h, right? So that's all for today. Thank you so much guys. Thank you so much.